Okay. Well, it is 9:02, and I think we are ready to start. And it is my pleasure today to welcome you to the latest installment of Arizona Preservation Foundation's Preservation in Place webinar. This one today focused on sustainability and historic preservation. My name is Catherine Leonard. I'm the State Historic Preservation Officer here in Arizona. I see some names trickling in, so I know some of you very well, and others I have yet to meet. That's good news for me that there's more work to be done, and I look forward to meeting you all, especially if you're here in the Arizona area. We may have folks coming from out of town or from out of state, and that is because with Preservation in Place, this was a webinar series that was created by APF and the Arizona SHPO during the pandemic to really serve the much needed function of bringing folks together to discuss preservation issues really from their homes. So that was the Preservation in Place. That year we were able to do our annual conference at home over Zoom, and this was back when Zoom was this weird concept that worked for some people and not for others. That initiative was so successful, we decided to continue it. Alicia Adolph, the intern with APF, has been more than generous with her time in putting these together. So this is our latest installment, and thanks so much for coming. Some of you are here because you have a abiding love of history. Some of you are here because you love old buildings, love the very concept of old buildings, the aesthetics, the design of old buildings. Some people are here because you love place, and you recognize that historic preservation is a tool for essentially cultivating your love of place. And today I want you to think a little bit about how historic preservation can be a tool for cultivating a love of the environment. It seems, at least in my line of work, I am faced with the concept of global climate change and water shortages here in the Southwest, drought and fire, and the need to reduce fuels for wildfire prevention. And I'm constantly challenged with having to look at projects and look at situations that are very forward thinking in their approach. These are projects that require solutions, taking us into the future for how we can sustain our existence here in Arizona. And interestingly enough, I work with a tool that is very much past focused. That would be historic preservation. But what these folks today on the call, or so not call, excuse me, on the webinar are focused on is using the tools of historic preservation to really advance the dialogue of how we can create a sustainable future for our cities and towns in Arizona and elsewhere. I've had the pleasure of working with Bob Graham and Simon Herbert pretty much for the entirety of my career, or at least the portion of my career at SHPO. And these are brilliant men, top of their field. And it is my pleasure today to be able to welcome you all to hear a bit about the projects that they've worked on and some of their thoughts on how historic preservation can really help us move the needle in terms of our efforts to address a sustainable Arizona. Okay, and with that, I will turn it over to Alicia to make some introductions.
Hello, everyone. Happy Earth Month. Thank you all for attending our Sustainability and Preservation webinar today. Remind you that today's webinar is recorded and will be on our YouTube channel titled Arizona Historic Preservation within a few days. And if at any point, if you have any questions for the presenters, put them in the chat and we will get to the Q&A at the end. So I will present our first presenter today, Bob Graham. Bob Graham is Principal Architect of Motley Design Group of Phoenix, Arizona. He has worked across the state to identify, preserve, and rehabilitate a wide variety of historic resources. The focus of his work has been in the areas of historic preservation, urban infill, and rehabilitation projects. He has been recognized individually for his volunteer activities and his design work in historic preservation with the Arizona Heritage Preservation Award, and also received the Young Architect Citation from the Arizona Division of the American Institute of Architects. He currently serves on the City of Phoenix Design Review Committee and is president of the Grand Avenue Members Association. So I present to you Bob Graham.
All right, thank you for that, Lisa. As she has said, I'm Bob Graham. Good, thanks for the introduction. I'll share my screen so you can see my presentation. So I'm not the world's foremost expert on sustainability. Freely admit that, but I've been doing preservation work for long enough and to really understand the issues between sustainability and preservation, and which are just becoming more and more important as time goes on. So the kind of things I'd like to go over in my presentation today is just looking at the challenges or the conflict between, or the perceived conflict, I guess I should say, between sustainability and preservation, and how buildings are just in themselves sustainable. Some of the special things that we have unique to Phoenix or the desert Southwest that would be a little bit more important for us to look at, and some different approaches. I've got a few projects that I can go through and show you how we've tried to apply both principles simultaneously to come up with some really great projects. So this is the question that I keep hearing when I come to have owners come to me, or having discussions with developers and people like that. It's like, well, aren't new buildings more sustainable? Because a historic building, you know, they're going to be just inherently energy efficient, is what we hear a lot of, is that you know, lack of insulation, those old leaky windows, all that kind of stuff. But for whatever reason, people seem to think that new buildings are just more sustainable. But economics have a lot to do with that. In my world, or in a perfect world, the economic situation should just automatically result in historic buildings being preserved. Why aren't they? Because the values seem to be out of whack sometimes. So why do economics get into the picture? Because the most sustainable building should be the most economic as well. So is it either or? Do you get either preservation or sustainability? Or do you really, do historic buildings need to have some radical upgrade made to them in order for us to survive the next 100 years as we face the challenges of climate change and rising populations? So there's some reasons for this. And the reasons that the economics are a little out of whack. One is this: demolition is artificially cheap. So the fact is, when somebody is looking at the cost benefit ratio between a rehabilitation project and looking at a building as being, oh, that old thing, it's inefficient, we should just tear it down, start over. That person is not looking at the true costs of demolition to society and to the world. Not just, you know, the fuzzy things that we like to talk about with the value of preservation, but the fact that, you know, the initial construction cost of that building has already been amortized. There's value there that is often not recognized or discounted because it didn't come up in somebody's bank balance. Demolition is inherently a cheap thing to accomplish. Partly because it's a low labor kind of thing, and people aren't always paid a real living wage, the kind of people who do demolition. And of course, all the environmental costs that have to do with if you got a landfill, there's habitat loss, natural area loss. The surrounding land around a landfill is typically depressed in value, and of course, future hazardous waste, groundwater pollution that older landfills particularly have a problem with, and the impact on the disadvantaged people who tend to be where we plant landfills. So these are all societal costs that are not paid by somebody who says, I'm going to demo that building. Wrong way. But the new construction, as high as construction costs are, and those of you who are involved in the building construction field know all too well, in the past 5 years, we've seen astronomical increases in construction costs. You can't build a house for under $200 a foot anymore. That's much good, and commercial construction sometimes much larger. But even that does not factor in all the costs of when you build a new building. So there are things about building a new building that are not necessarily sustainable, because you've got all of these externalized costs as well. You've got the costs of, again, environmental damage of the entire supply chain, everything from sourcing materials, which can be clear-cut logging, as you see on your screen there. That's a real place not too far from a place I visit in Canada frequently. Canada has terrible logging practices, by the way, compared to the United States. But so clear-cut logging, mining, loss of habitat, you can read down the issues. There's just a tremendous amount of impact that is not paid today. It's paid by future generations. It's paid by people who are directly affected, negatively affected economically by these things going on near them. So these factors tend to, underwrite the cost of new construction. Our entire land use policy framework also is something that subsidizes new construction projects over existing projects. So we have a issue, of course, here in Phoenix, where way back in the 1970s, large swaths of downtown got overzoned. By overzoned, I mean they were zoned for very dense uses that were not needed at that time. That raises the cost of value, the value of the land, which makes the buildings that are on them less valued by comparison. When the land value starts to exceed that of the building, you're going to be incentivizing new construction over preservation, and incentivizing, once again, people to demolish buildings. Densification, which is a perfectly laudable planning goal. Actually, that's one of the things we want to do to make a more sustainable city, is make better use of land. So, but that has a side effect, as does all of the community development needs that we know. And so those of us who work with city councils and politicians, we know that we have a housing crisis. We need to build housing. There are blighted areas that need to have reinvestment made in them. And cities need to have income to operate. And so all of these things, new construction is what fuels the furnace on those. So all of these things together mean when a developer is looking at a project and he's looking at whether he should be, whether it's more sustainable and whether it's the most economic for him to to clear the land and rebuild something new. It's just cheaper. It's less risky. It's easier to finance because banks don't like to lend on complicated projects, or they're less inclined to lend on a renovation project because they're not considered clean. So all of these things together really mean that the system is kind of rigged against historic buildings. So, which is, as I will show, it's kind of against a goal of sustainability. It's ignoring some values that are there. So in Phoenix particularly, and this is not really just Phoenix, I'm using Phoenix as an example, but it's really the entire desert Southwest. We have some unique sustainability challenges here, and it has to do, of course, with our desert climate and the different things that our corner of the country have to deal with from a livability perspective. So climate change is going to affect everybody. Climate change is going to affect us by we're already hot. So we gain a few degrees of temperature rise. It just makes the livability of the city harder and harder. So climate change and the heat island effect, particularly as we pave large swaths of cities, that's a big thing to the livability of our cities. Water supply, everybody knows about the issues we've got with that. Energy use. The energy use in the desert Southwest is primarily for cooling buildings. So that's a big thing, and that's one of the reasons that you see so much focus on historic preservation, sustainability questions centering around how well a building is insulated or how much energy you use is just for the cooling. But the other things we have are transportation. A place like Phoenix, I hear people commuting an hour across town. That's not an efficient use of energy. So this factors partially into urban form, and our historic buildings tend to be clustered in the downtown area or in older areas of town. But the urban form then was one where people tended to walk, people tended to take streetcars, just more efficient and more compact. And so that's one of the things that the way our cities have developed is makes it harder to make a sustainable city. And energy cost and source impact, that's really talking about renewables versus, most of our power in Arizona still comes from fossil fuels. I think the majority of it is coal and natural gas. But so renewables are certainly something that we have in abundance in our solar. How many days a year we have a solar power potential compared to a lot of places. So there are a lot of different aspects to sustainability as a larger topic. Those of you who are familiar with the LEED system and other rating systems, there are just so many angles between indoor air quality and renewable materials, just a long list. But to me, these 5 are the things that are going to make the most difference to us as to whether Phoenix stays a place that you're going to want to be living in 50 or 100 years. So why did things get this way, right? When old buildings were new, the materials that people tended to build with were relative to labor cost. They were expensive. Labor was cheap. We had people to do all sorts of manual labor. Transportation costs were high, so people tended not to do things that required a big haul of heavy materials. They could get things in by railroad, but once you start hauling things around with horses and wagons, that makes things less economic. There was no refrigeration, so you had to design your buildings in a way that you could survive without mechanical cooling. At least before the turn of the century, everything was done with animal power. We have all the canals that were built, the railroads and everything. That certainly was people in part, but the real engine of all of this was, mule skinners driving mules. And you got to admit, the people in this photograph are a lot tougher than we are. So this is a Saguaro Ranch in Glendale. This is the adobe house at Saguaro Ranch. And these are the people who had to live here without air conditioning. They built this house out of local materials. And they built it in a way that it was possible to live. Notice they're eating their watermelon outside because it was probably the most comfortable place to get together. So people were pretty much forced into a sustainable situation is what I'm trying to get at. So as we look at historic buildings, existing historic buildings, well, I guess they're all historic. I guess they'd all be existing, surviving historic buildings. The materials they were built out of are inherently sustainable. They were almost always locally sourced. You don't see a lot of historic buildings, at least in Arizona, that were built of stuff that was manufactured in Chicago or anywhere else. So you tend to get things like stone, adobe, brick, and of course wood being the things that most historic buildings are made out of, the primary materials. Those things all have an enormous amount of embodied energy. So somebody had to cut that stone and make it into blocks, and somebody had to make those adobes and lay them out in the sun to dry. Somebody had to stoke the fires to burn the brick. All the work that it takes to cut slabs of wood to make buildings out of, that's all something that's already been done. And so that's in the building, and to scrape that up and put it in a landfill is just doesn't seem like a real wise angle. The buildings themselves, these are all probably recognizable to most of you. Look at the size of those windows. They were operable. They let in a lot of natural light. I don't remember the last commercial building that I've been involved with as a new construction project that anybody even thought about operable windows, because it makes HVAC systems very difficult. But it's important, and these buildings all had high ceilings so that the hot air could rise in the room and make the livability of the space more comfortable. These tended to be thermal mass type buildings. The buildings we build today are largely based around the idea of resisting heat flow. So lots of insulation. That's where you want to get your R38 roof and your R19 walls. Well, that's all an approach that has to do with trying to resist heat flow. The strategy in almost every historic building was not that. In Arizona, it was a thermal mass solution of delaying heat flow. The idea that the building would heat up overnight or during the day. It would take so much time to get for the heat to get through a wall that by the time the sun went down, it would re-radiate that heat outward. So this is the same phenomenon that you see where you say, well, gee, I wanted this old adobe building and it felt so cool. Well, that's because those walls are so massive that they never were able to really heat up during the day enough to re-radiate indoors. It re-radiates it outdoors when the sun goes down. Eaves, shading, porches, just a lot of good adaptive things, because if you were trying to live here once again, turn of the century or up until World War II even, these are the things you needed to do to be able to have a level of comfort in your your city. There's also the cultural and livability benefits. So what I'm contrasting here is saying that the livability of a place, as in, does it have the richness, the interest, the friendly character, the walkability, all of those sorts of things that are really part of sustainability. And if you look at the two right images here, the top one is an image of Clifton, Arizona. This is the Chase Creek area, which is about one of the most interesting little twisty canyons of interesting buildings that I know in Arizona. It was a commercial district. It came about because it was built in an era when everybody walked or rode a horse to get to their place of business. Very similar to Bisbee. More people are probably familiar with Bisbee and the sort of climate and character that a place like that has. The one under that, the lower right image, is I would challenge any of you to tell me exactly where that is. You know, maybe if you live close to it, you might know. But this is a totally anonymous Phoenix strip shopping center. And you could say, well, I could have told you that was somewhere in Los Angeles, and you would look at the palm trees and say, yeah, it might have been Los Angeles too. They're the kind of places that don't have a sense of place. So historic buildings do that, and that's part of sustainability. And the architectural interest. Lower left here, this is a more modern commercial area, the Miracle Mile, but it still is something that has a sense of place and has a reason for it to be coming back. So if you agree with my premise that saving historic buildings is inherently sustainable, how do we resolve that potential conflict between trying to make big improvements that increase energy efficiency and these other things that historic buildings sometimes do have some drawbacks with, and keeping historical integrity? So this is just the 1, 2, 3 of that. The way we always work with these historic preservation projects is the first thing you do is you figure out what it is about the building that makes it historic, right? So those are in the biz known as the character defining elements. So in the photo here, this is the Welnick Arcade Marketplace on Van Buren. You can pretty quickly spot the number one character defining element on this, which is the cast stone, for instance. So cast stone, the pattern of fenestration on the building, the awning, you can just name these things off. And on some buildings, it may be things like the interior walls being exposed brick. It could be a lot of different things, but it's different, a little bit different for every building, or for at least there's a wide disparity between buildings because they're different, they're important for different reasons. But the reason you do that is the reason you focus on identifying what those are is then you know what it is you're trying to say, because there are things about historic buildings that you can change without being a negative impact. So once you've identified what they are, what are your sustainability goals, and how would you go about addressing those? This is a list of things that are sort of focused on that original, addressing that original list of things that are specific to the desert Southwest. So shading, very obvious. Cool paving, cool roofs. So these are typical approaches that we would see to a hot climate, a hot, sunny climate like ours. Then you look at ways of making number one and number two work together. How can you implement upgrades to your building in a way that does not have an undue impact, or at least not an irreversible impact to the historic building? And look for creative ways of doing it, because there is no one way to do these things. There are a lot of opportunities that historic buildings actually offer that might surprise you. So let me give you some examples now. So 22 Jackson is a building that started out quite unappealing. It ended up like that. The owner of this, Dudley Ventures, is the owner, still the owner. Their goal here was to try to not only get the building back to a level of historical integrity. Most of the stuff you see here was actually present behind this stucco. So this was one of those cases where it was there, it was just not recognized. And so we were able to get the stucco off. The parapet's a reconstruction, but it was based on historic photographs. So that's a fair game solution to something like this. But he not only wanted to preserve the building and honor its historical integrity, he wanted also to try to get it certified, LEED certified. I'm not sure if he ever actually followed through and did it. I'm going to give you a little side comment here and note that I'm not a big fan of the U.S. Green Building Council and the LEED system, because it is actually, in my opinion, angled towards new construction. There are things that it wants to require you to do in the name of energy efficiency that will destroy historical integrity. And I run up against this many times. The fact is, the LEED system does not recognize all of the aspects of the inherent aspects of sustainability that I went over in the first half of my presentation. But it's still a good system to look at in terms of a checklist of things that you can and should do if you can in the name of sustainability. I just think it needs a little bit more weight given to the value of existing buildings. So in this building, we did a number of different things. There were some fairly complicated interiors that I'm going to show you that required some creative work being done on preserving the wood trusses. We made a lot of use out of natural daylighting to reduce the lighting load. Interesting reuse of materials, and of course, just improvements to the envelope. But how you do the improvements to the envelope is pretty important. So this is a warehouse type building, and this is one of the classic problems that everybody wants to do these adaptive reuse projects in old warehouses. You've now been in probably 10 brew pubs this year that have similar treatments, because that seems to be where brew pubs want to go. But getting back to that list of character defining elements, in a warehouse type building, some of the most important character defining elements are the fact that you see the interior side of the brick wall, that it is particularly an unfinished space, that you see the truss roof, and that be an exposed structure that conveys its industrial background. You're not trying to make an industrial building look like something more finished. So that's kind of a key thing. In this case, we wanted to make sure and preserve those trusses because everybody actually wants to see the trusses these days. However, this is a one-story building. What you can't really tell very easily here is the way the building was constructed. There was like a slot down the middle that was at grade, and then on each side, if you can see my cursor, at each side on the left and on the right was a dock height floor level. So it's a two-level building, which doesn't work very well for use. But what the owner needed more square footage in this building, and there wasn't enough headroom to do a mezzanine. So the creative solution here was, let's preserve enough trusses up in the front to really be able to show people how it originally looked. But then in the back, we were able to modify the trusses, and we literally cut a slot out of the bottom of the trusses for the back 2/3 of the building approximately, that enable us to put this two-story section in here, basically a mezzanine story that went and gave them some additional floor space. But we did preserve probably 75% of that material, and actually makes for an even more interesting interior in some ways. Daylighting was a big thing. So I'm a big fan of tubular skylights because it doesn't take a lot of modifications, a lot of structural modifications. So the trade name most of you are probably familiar with would be Solitubes, but there are other manufacturers, and I'm not paid anything by the company. But it's a really good way, particularly in buildings that have dark spaces towards the interior. You can put a bunch of skylights in these buildings at very low cost and reduce your lighting load tremendously. And so this is something we like to do whenever we come across one of these buildings with a large interior like this that's got spaces that are farther away from the windows. But of course, the windows themselves are part of the daylighting strategy. We opened them up as much as possible. These are original window openings that had been closed in, and let that light in as much as possible to daylight at least that front part of the building. An unusual aspect of material reuse on this building was originally constructed with a corrugated metal roof. So it was trusses with corrugated metal, which you can imagine was not a good energy efficient material, because the sun would just beat down on that roof, heat it up, and it would just radiate it on the inside. So you could ventilate it out, but the adaptive reuse here was as a commercial office, so that wasn't going to work. And structurally, we were required to put a roof diaphragm on this building. In other words, we were required to take all of that corrugated metal off and put down plywood. So there is plywood on top of the trusses and on top of the joists, but we salvaged all of the corrugated metal that came off the roof and reused it. We cut it into strips and we used it as an interior finish material, which did a couple of things. It diverted all of that corrugated from going to the landfill, but it also added a tremendous amount of recreating the original significance of that open structure. And we're showing people what that this was a corrugated metal roof building. Most people who come in here wouldn't even know that it wasn't. It is the original material, just reused. But we've done it in a way that we were able to make the building more energy efficient and meet the structural requirements as well. Because of course, we did insulate this building. It's all on top of the roof. You can put rooftop insulation and just a conventional roofing system because it's all behind a parapet. You don't see the roof. We did not insulate the exterior walls because they are performing adequately as a mass wall. Actually, the side walls on this building are up against other buildings, so there's even less of a reason to insulate them. All right, another project that was designed with, along sustainable principles, the Rose Eisendrath House in Tempe. So if you're familiar with, this is north of the river in Tempe in the Papago Park area. It's occasionally open to the public. I believe it's a city-owned building. This is a Robert Evans designed Adobe building, one of his biggest and greatest Adobe buildings. So Robert Evans also was the architect of the Jokaki and Bell Towers. Pretty much any of these major Adobe buildings that you see that were built in the 1920s, 1930s, they're in the Phoenix area, are likely to be Robert Evans buildings. So this, as a city facility, the city's policy on all of their projects is to try to do them sustainably. I see I'm probably got about 7 minutes left, so I'm going to pick up the pace a little. A number of different things that we were implementing on this building. This isn't the sexiest slide I've got, but this is the floor plan of the Eisendrath house. But this is showing you, I love VRV air conditioning systems for historic buildings. So most air conditioning and heating systems that we see on buildings of this size are forced air systems. You know, you need a duct. You need 2 feet by 4 foot duct running around your building. When you're trying to rehabilitate an old Adobe, that means cutting big holes in Adobe walls and doing major damage. The great thing about a VRV system, VRV stands for variable refrigerant volume. Only pipes are running around. So all those little lines you see, those are like 2-inch diameter pipes. You just make a little core drill through the wall, and you can have a remote air conditioner, which actually sat up on a hill behind this house, and run piping around to the various units to achieve your air conditioning goals. Very low impact. We've used it on at least 3 fairly major historic projects. So and I should say they're extremely efficient systems, because they even have the ability to sort of pump heat around the building. So if you have one side of the building, say that's on the west side, and it heats up, and the east side is still cool, it can recirculate just through the piping system. Some of that heat, it can move it around the building and make it more efficient that way. So it takes into account imbalances in the system. They are expensive, but it's often worth it. We use rainwater harvesting. I mentioned water. How do we irrigate the landscape around this thing sustainably? This building had a swimming pool that had been filled in for years. So this is on the lower right slide. This is like, it's a raised swimming pool on a terrace. The upper slide is the top of the swimming pool. This orange paver material, that's the infill that they did in the pool. We excavated that out, and we lined it so it would hold water, and we put a cap on it and a pump system, and all of the runoff from around the building and off the roofs all goes into this old swimming pool, and then is allowed to use to drain off to the landscaping. We went to some unusual lengths to preserve rather than have to replace roof timbers. These were all undersized for the new use. We had a change of occupancy, which required higher structural loads. And so we were able to put just reinforce what was up there with a fairly creative system of steelwork to be able to preserve that in place and save not only the material that was original, but all the work that we would have had to go into and expense to take them out and replace them. DeSoto building, many of you are familiar with this. It's now a gymnasium of all things, but this is the before picture, if you can believe it. There's the after picture. This was also designed to sustainable principles. We did some energy modeling on it, and things like that. A lot of the little lead things that you'd have in the lead system list were actually fairly easy to achieve. But some of the things that were not so easy to achieve, this was a roof that was on the edge of being thrown away. You can see on the upper left, these trusses had broken in many places just due to their original design was very poor. When we got into the building, the entire roof structure is being held up by a forest of shoring, just to keep it from collapsing. And the owner was prepared, if necessary, to take that entire roof system and take it down, throw it away, and put a brand new roof system in there, which is what 90% of owners would have done. But we were able to find a way to put those things back together, reinforce them with some supplemental steel. But the problem with the trusses wasn't the individual members, wasn't the wood. The problem with the trusses turned out to be the connections. And so we found a way to just reinforce the connections with lots of bits of steel, which of course it saved all this original material, as well as saving the material that would have gone, material that would have gone to landfill and the material that would have had to replace it. Again, this was a similar situation to 22 Jackson. The exterior envelope, we were able to do all the insulation on top of the roof, so we could preserve that interior look. And to cover up the interior walls in this building would have been a sin. They were just dripping with character and age. So my essential message is that preservation is the ultimate in sustainability. This is the Hayden House. So if there's any building in the Salt River Valley that demonstrates how something can be sustainable, this building is the oldest surviving Anglo building in the Salt River Valley. So if you take away, Indian ruins and talking about first settlers, this dates to 1878, and it's the structure of this thing is probably 90% dirt, and to be able to preserve that in place not only is sustainable just from a material standpoint, but think of the importance of things like this to the livability of cities and the ability of somewhere like Tempe to be able to have an anchor to call their, it's basically, this is the birth of Tempe right in front of you. And if that's not a positive aspect to the livability of your city, I don't know what is. So thank you, and we will go on to the next speaker.
Thank you, Rob. That was a great presentation. Learned a lot. Reminder to everyone to put your questions in the chat for the Q&A following the presentations. And our next presenter is Simon Herbert. With a preservation career spanning more than 40 years, Simon Herbert retired from Pima County in 2021 after a 15-year position as architectural preservationist and program coordinator. Prior to working for the county, he taught building preservation trades at the college level for 10 years. While at Pima County, he was involved with numerous county-owned and affiliated historic properties, helping with documentation, project development, and frequently participated with actual repair work. Perhaps the most rewarding project was Canoa Ranch, where large numbers of adobe structures and ranch structures were at risk. He also ran groups of volunteers in building repair sessions where work included the rebuilding of large gates and extensive repair and building retack corrals. Over several years, he taught students at Cienega High School in Vail to repair wood-framed windows for a historic railroad building. In retirement, he continues to consult on select preservation projects, is an accomplished architectural photographer, and a published author of historical fiction. Sent to you.
All right. Okay. I'm going to cover a small swath of preservation projects that I worked on when I was employed by Pima County, and also a few other projects that I've been involved with since. This is really the Bible that we would turn to on any preservation projects, and in fact, anyone working with historic buildings where they especially need to go through a process of approvals will need to have their hands on this document. It's actually a really rich, wonderful, well illustrated, well-written document that is full of good examples and for the most part, I think, sound ideas. I don't agree with everything in them, but it really is the go-to Bible for preservation, rehabilitation, restoration, and in some cases, reconstruction, most of which I'll touch in this presentation. Working with Pima County was a unique experience in that they had a very solid relationship with the State Historic Preservation Office, the SHPO. And projects that would come before the county were often bond funded, meaning that they floated a public bond and the voters would vote on it, the money would come in, and this would fund a set number of projects that would be on their menu. And the way to get the project from start to finish was to begin with hiring a historical architect. And they have something called a qualified contractor list. So that would begin the ball rolling. There would be a team development. They would discuss the planning, what they wanted, what the goals were, what the approach should be. And with drawings in hand, you then go through plan review process, which often would mean putting the plans before the SHPO office for their input. Once everything had been approved, and the process takes some time, sometimes 1 or even 2 years, then you hire a building contractor who already has some qualification based on past experience that they can do the job. There might be in the county 6 or 8 qualified contractors, and they usually pick one who is most appropriate for the job. Once that gets underway, there's project oversight, building inspections from the county, the occasional visit on site by SHPO staff. And once it's completed, then you get a certificate of occupancy and people can move in. The building process can be several months or a year, depending on the size of the project. Canoa Ranch, as mentioned, was a really rewarding project. This shows a set of buildings at the ranch that were completed roughly, I'd say 2008, 2009. So this is not a recent photograph, but I like it because it does show what the buildings looked like pretty much upon completion. Goes back a long way in history. It's an 1821 Spanish land grant. So this is even before Mexico was Mexico. And the existing buildings date from almost the turn of the century, late 1800s, to the early 1950s. This was taken in the 1990s, and it shows part of the building you just saw in a state of collapse. It didn't fall down by itself, but it was lack of maintenance that brought it to this condition. As typically happens with buildings that are not attended to or maintained, water does damage. In this case, clogged roof drains. The water built up, it leaked, the adobe got wet, it couldn't support itself, and the roof collapsed onto the building, and it ended up looking like the top photograph here. The remaining wall was braced temporarily until work could actually take place. So the roof from here is gone. This wall is partially missing, and it's missing all the way to here. The team has to do extensive research to determine the best approach. And I always like to point out that the architects and the county team working on this were very open to listening to the contractor who came on board, and they were able to come up with very creative solutions for tying old and new walls together. Incidentally, they were also adobe, and the windows, you can see an old one over here. The new windows, in this case, were replicated by the contractor's carpentry shop, and they did a very, very good job of copying the original method of construction. They don't have insulated glass, and they're able to maintain the true divided light in the window with the right thickness. And I really wanted that to take place. Here's another building, also the victim of clogged roof drains and roof collapse. Another adobe building, this one from the 1950s, and actually the last building to be constructed at Canoa Ranch. You can see the original adobe wall here and the new adobe wall being constructed by the contractor. And the bottom photograph shows what it looked like upon completion. Right now, there's an air conditioning unit that sits outside here, and this patchwork of stone covers the entrance to a dry well. There's a roof scupper right here. The water shoots off, lands on the stone, and travels underneath to a dry well where it dissipates. They haven't introduced water collection at this point, but that may happen in the future. Incidentally, the building was constructed with metal frame windows. You can see them here and here. We found that these were constructed by the Torrance Company in California, and so the architect and the builder simply went back to Torrance and said, "We need two more like this," and they made them exactly as the original ones had been made. The need for making adobe, obviously with this amount of damage, was huge. And the original adobe had been made from dirt on site. They'd simply gone out to a suitable location, brought the dirt back, mixed it, added straw, and there was a great variation in quality. Because of the archaeological sensitive nature of the site, we were not able to go back to any site and simply dig dirt. It had to be brought in, which also gave us the opportunity to find a better brick that was a standard that could be used. And you can see some of the 8,000 bricks in this lower area in the process of going through their drying rotation, which takes about 2 weeks. These are made flat on the ground, like this one, in a mold. Immediately the mold is taken, and then they're allowed to dry, and then they're flipped. Every couple of days, they're rotated so that they all dry evenly, and then they're put into the wall. Here, a mason is doing a really nice job of applying new adobe to this. This part up here was a concrete collar beam that ran around the entire house. So where that was missing, that also was included. The state of the buildings when first seen was really depressing, but by carefully dismantling areas that were fragile or broken and then reconstructing them, the building came back relatively quickly into a stable condition. The thing about these buildings made of adobe is you can't just let them sit because you've repaired them or restored them or rehabilitated them. There needs to be constant monitoring of systems to make sure that things aren't going awry again. And there were some design issues on this building that I would probably, if I'd known better at the time, I would have suggested changing. You see these tubes sticking out, they're called canales, and they're essentially roof drains. The roofs drain to these points in little boots on the roof, and then they shoot the water out. These are in the original location. Well, there are problems with the original location, and you can see that one is directly over a window and the other one is directly over a door. Because it had been decided to use the same dry well system, right in front of the door is this area of boulders over a steel grate that nobody can actually walk on. It's too dangerous. So I put a walkway of steel over that and rearranged the rocks to try and hide it. But I would have suggested moving these drains to a different location, maybe one over here and one over here, to redivert the water in a safer manner. The adobe site walls, very important for the ranch because they help to keep cattle, which were moving from the ranges and grasslands into the corrals, from getting into the gardens and the houses. So the site walls formed a very important job. Most of them were in some state of disrepair, some in total collapse. So there was repair and rebuilding that went on, and all of them had to be recoated with lime plaster. We worked with David Ubetta, formerly of Tumacockery in the National Park Service, who advised us on the kinds of mixes. They even brought National Park Service teams to the ranch to help show us how to make use of these traditional materials, which are very sustainable. Again, recoating the walls is important every couple of years, and we were getting all manner of problems from water infiltration that occurred because of this concrete lip. The concrete was original to the walls, but they did not have a drip edge. So where we replaced the concrete caps, they included a cast drip edge in so it would shed the water before it got into the top of the wall and then damaged it further. We learned a hard lesson on these concrete walls because the original walls had been coated white and they had been whitewashed with lime wash. And so we applied it to the concrete caps, only to find that after several hard rains, it was washing off. And there was a heat differential between the adobe wall below and the concrete cap that was bare concrete, to the extent that the cracking would separate right under the concrete at the top of the wall, which only allowed more water in and encouraged damage. So we found a paint company to work with us, and they came up with a high performance paint that was an epoxy paint. And we painted those caps white, and the problem was solved. So we were able to get the white cap that we wanted, but it also performed much better. What I'm trying to say here is that there is a real process of learning when dealing with historic buildings. One of the most important things is working with lime. And this is something you may have seen in your travels in the preservation world. But the lime cycle begins with limestone that's then crushed, and it's heated to around 1200 degrees, and it drives off the carbon dioxide, which gives you quicklime, which is really a very white-looking stone, but it's not limestone, it's quicklime, when you add water to that, it gives off a tremendous amount of heat, and you end up with hydrated lime, which is really a paste-like material. When you take the hydrated lime and it's properly aged, then it's used as a mortar or an additive or a lime wash, and the air gets back into the limestone, so does the carbon dioxide, and you end up with a very hard material similar to limestone itself. So it's a tremendously sustainable material, very traditional, not easy to work with, and therefore it's not often used for modern buildings, extensively used in restoration work. The team had to look at what the period of significance was for the early ranch. The patina that you see in the top photograph had some appeal to some people who were on the team, but when we studied the photographs and learned the culture of the owner of the ranch, who was Howard Manning, it was clear that he was very keen on things being in good maintained condition, which means that things would look clean, they'd be repaired, and that was the direction we went. So the cementitious coatings that were on this wall, for example, were removed and replaced with lime plaster and lime wash. The windows, which we did evaluate very closely, were deemed to be too far gone, but we kept them in storage, but new ones were made which replicated them along with new frames. The color of the doors were white initially. We changed that to blue when we had photographic evidence to determine what they should look like. But all the original hardware holding this door, it was taken down. The roller bearings were all flushed out of sand and dust and then re-greased, and the doors worked just as they should, if not better than when they were built. The garage for the Manning cars was wood frame with stucco, and the bottom 12 inches or so was completely rotten. So the contractor replaced that, put a new floor in, and it became the men's and women's bathroom for the ranch. And the doors had to be reconstructed, but it used the original hardware, which was very appealing, because when it's closed, it resembles a garage, and when it's open, it looks like this. Some of the interior projects I worked with volunteers on were in the main house, and the house, I'm not going to show you an overall view of the house, but it was expanded in about 1948 when the owner's son married and he and his wife moved in. And they created a dressing room for both of them, massive space with 32 drawers, most of which had been chewed through by pack rats. And this gentleman here was a retired engineer, and he lived in a community where they had a carpentry shop. And so he would bring in these little strips of wood, which he used as replacement runners in the drawer slides, that were a selection in 2 millimeter thicknesses. So we always had an amount to draw on. But together we worked using wood epoxy consolidants, repaired wood, and then repainted them to match an early paint job and color scheme that had been used in this room. Interestingly, if you look at this slide, these are all a battleship gray. These were repainted what was originally the color for the entire room. And we surmise that because of the end of World War II, there was a large amount of navy gray paint surplus, and they probably got a good deal on it, because we couldn't imagine young Mrs. Manning choosing battleship gray for her own dressing room. But an extensive repair project that ended up being well done. The foreman's house is probably the oldest building from the late 1800s. Very tall ceilings, 12 to 14 feet high, and roof drains, as you can see here. These were replicated in the repair work. But once this cementitious coating was removed, it revealed very poor condition of the adobes. So it took some time to find the right combination of earthen plaster and lime plaster and lime wash to bring the building back. The chimney was starting to collapse due to a poor foundation, so this was removed and then rebuilt on a new foundation. It's worth noting in this photograph, these windows, which big sheets of glass that were put in the 1960s and certainly not original, they caused us all kinds of structural issues, which we addressed with SHPO. Here's the building shown complete. It has replacement circa 1950s steel windows. These were kept. There's one original wood window under here where it was protected, and that one was simply repaired and put back into service. Inside the room where they made these windows, there was some real structural issues. These beams that you see here are load-bearing, and they rested on not much of a lintel they had put in when they put these big glass windows in. The reason for the columns and supports was to prevent these beams from working their way downwards due to gravity. And somebody in the process of the past had actually got a 2x6, which is seen here, and jammed it up right underneath this beam, and it rested on the fireplace, which had a little sag in it due to the weight redistribution. So SHPO agreed with us that the window should be refilled, so it shows them now infilled, and the woodwork was removed after careful documentation, numbering, taken back to our shop, and that's where we rebuilt it. Replastering of that same room in lime plaster, lime wash. And I came up with this structural device to resupport 3 of these beams which needed help, especially the center one. So we used recycled lumber from other projects, placed on top of the fireplace so that we have good vertical support. And then after putting things back, it started to take shape. This is the original wood put back in place, a new mantle with electrical points built in, and the rebuilt bookshelves created this space in the living room. So I was very happy with how this came out at the end. To the right of this room, there's a kitchen, and from another county project, we found this stove, and I had insisted it be kept in storage until some other use could be found for it. And I had it brought here after cleaning and made some repairs to the rear manifold and fashioned something out of dry vent material and air conditioning to make this exhaust pipe. Obviously it's non-working, but it gives the impression of a working stove. The knobs, we only had one knob that was original, so I cast a master mold and then made duplicates in this little rubber mold using special epoxies, and here they are on the stove. They haven't yet been repainted to match this one, but they were a very good exact copy of the original. So you can see we go from the very large to the very small in projects like this, but the attention to detail is important. There needs to be a consistent flow of ideas and materials. The livestock corrals at Kanoa are made of mesquite wood, and their design is traditionally called retake, which means to stack up. The fences weren't used to hold cattle other than for the list shown here, which included the branding, castration, dehorning, and so on. But you can see the extensive network of gates and fences And I came up with a conservation plan for this after numbering and lettering everything that we had. So we knew if we took a gate off where it went back, for example. But we had 1,200 linear feet of rehabilitate fencing to repair or replace and 52 gates. The reason for the size of the rehabilitate fences was for bulls and other cows like this one, very large and heavy, and they had to be big enough to resist them wanting to get out. If they were out on the open range, the first thing they wanted to do is not be in a fenced area. Lack of maintenance again had led to collapse and disintegration of many areas of the fence. And we had to understand how they were built and how to repair them. This shows just a cut-through diagram of a typical fence detail. Fortunately, we had some local volunteers who really enjoyed working on the fence, and we were lucky to have this gentleman, Tony Salcido, and his cousin Frank, and also these. Tony had grown up on the ranch in the 1950s and had helped his father repair the rehabilitate corral. So he remembered how things should be and how they were put together. So he was the lead person on the reconstruction. Very hard, nasty work, very dirty. Here is a fence being dismantled ahead of reconstruction. New posts had to be put in. Here are the gate posts with string lines running on the inside to show where the new posts would go. We started using a machine auger attached to a tractor to dig the posts, but it was so cumbersome and slow that we resorted to just digging everything by hand, and it went a lot quicker. We recycled all the wood we could. We did have to go out and find a lot of the replacement uprights. And in this case, an existing tree, which was now dead, had been used as a part of the fence. So we recut wood to fit in there on this side and the other side so that it would fit in as part of the fence. Here is a complete section being rebuilt. And here is a reconstructed part. The part from here down to roughly here is original. Everything else is reconstruction. And this is one of the 52 gates that was reconstructed. The only thing we did was differently, that is to install a turnbuckle steel rod on the outside on both sides so that we could keep the gate from sagging, but everything else was the same. All original hardware, locking mechanisms, but all new bolts. There was no way we were going to reuse the old ones. They were just too damaged. And then rehung it on the original hinges. They worked very well indeed. Switching gears to the Ajo train depot, this was another county bond project for the town of Ajo. And this served the Tucson, Cornelia, and Gila Bend Railroad starting in 1916. This is a 1920s photograph. It's obvious that these had big open arches as part of its original design, but later these were enclosed. And you can see where the cracks had occurred. They put windows in so they could use it for offices. A lot of the original detailing is still there, which was extremely helpful. And the tracks are still there, even though no trains run. This was the completion of the rehabilitation with its spaces restored. The entrance to the visitor center, which is what the building has become, and the interior shots showing very tasteful retention of original ironwork here and replacement, almost reproduction light fixtures give a very nice tone to the building itself. On one end, there was a platform, a raised platform that was at train height. And to make better use of the space, the platform was removed. And that's what this band of wood is here. It covers the rough concrete where it was cut off. And inside this room, they were able to squeeze in a small meeting room for private discussions. Another project with a railroad theme was the 1915 section Foreman's House that was a project of the Vale Preservation Society and J.J. Lamb, who coordinated with the Vale School District, who was having a new elementary school built in Vale. And this building, although historic, it had already been moved from its original location to closer to Tucson. And so over a long period of time, they raised funds and had the building moved to Esmond Station Elementary School. And here it is squeezed in between brand new buildings, and it has become a special training lab for the students. But getting to this point was no easy task, and I was asked to help with the windows on the building, all of which had been removed during the moving process and had been determined to have lead paint. Unfortunately, I wasn't part of the project at that time, and they elected to have sandblasting of all of the frames and windows, which removed a lot of the wood, leaving very ridged material. And that made for some very complicated repair work. I'm not going to go into the whole detail of how we did this, but here is one of the larger windows ready to be reinstalled. Everything is numbered. It's braced for moving. The tape is on here to remind people that there is glass in there. We weren't allowed to put back single pane or double strength glass. It had to be safety glass because of this being a school, which added weight to the windows. But the students were remarkably good in helping. The staff were also very helpful. We pretty much occupied the shop for months doing this. The hardware was taken off and stripped of paint, repaired, repainted, and then re-greased so it could be installed. The students working on a bench with a member of the staff. These are the wood frames put back in on top of the siding. The color was original to the building. I did some very simple paint analysis, and we matched it to Sherwin-Williams paint colors, and that's how the paint colors were put back. This shows the building pretty much completed. One of the ceremonial openings. Here's J.J. Lamb. Current project I'm working on is for Valley of the Moon here in Tucson, working with them as a consultant. Last year, I completed 3 reports on the 3 main complexes. A very unique 100-year-old set of structures built almost completely by one person with little building experience or knowledge. And it creates challenge buildings like this one. It's called the Cathedral. It's made out of thin shell concrete. So he used galvanized pipe, which runs on the corners up here and also down this way. He would put chicken wire on the inside and then using shuttering on both sides, fill it with concrete, lay it up. Unfortunately, he chose to do the same thing with the roof. And because of lack of structural integrity, the concrete started to deflect downwards to the point where we have a 15-inch deflection on one side and a 17-inch deflection on the other. So the structural engineer is currently reviewing the best way to deal with this, but very likely there will have to be a different system in place that preserves the exterior walls, but allows for a roof to be flat the way it should be. Over the years, a little forest of supports have grown up inside that room to keep the concrete from actually pulling downwards and tugging the exterior walls inwards and destroying the building. So this is one of the big challenges we're facing on this one. Okay, I'm going to shift to something a little more personal. Here's a picture of me around 1961. It's about 5 years old. I'm here with my older brother and my father. We're standing in front of this building, which is the 1937 Art Deco style terminal for aircraft, the first airport building that the island of Jersey, which is very close to France, ended up with. It was at the time lauded as a beautiful design, appeared in all kinds of books on architecture and architectural history, and personal connection too, because my uncle was the first manager of this airport until he retired in the 1970s. Here is the airport shortly after opening. The biplanes are passenger aircraft that would have flown from England and also France. Has these wings with platforms above so that the passengers can view it. Unfortunately, the states of Jersey who owned the building wanted to demolish it. And I went to school with a man who became a reporter and then a filmmaker and an ardent preservationist and politician locally in the island. And after we exchanged some emails, he asked me to write a letter to the states of Jersey as a professional preservationist, because I think it was hard for locals to get their point across that this building was valuable. It had great meaning to the island and its history. This is where the Germans landed in 1940 and where my uncle surrendered the island to the Germans. He had to call the chief politician and said, the Germans have landed. You need to come up here and surrender. So there's a lot of personal history as well as island history. And I was quite driven to write this letter. And you can see in this gray area the beginning of what I wrote. And in this last slide, it shows the terminal building with some modern modifications, but also a lot of accretions that had happened over the years removed. They were actually removed in preparation for demolishing the building. And I laughed and smiled when I saw Alicia's quote from Carl Elefant. The greenest building is the one that is already built. That's what I had written in the letter in 2021. And my parting words in that letter were, in other words, reusing a building almost always yields fewer environmental impacts than new construction when comparing buildings of similar size and functionality. In these terms alone, keeping the 1937 terminal is the more sustainable and affordable action over having it demolished. Fortunately, there were some people in local government who fully supported not demolishing this building, and it was proven that their premise for wanting it demolished, which they said was air safety and following the law, turned out to be completely false, and that they simply had chosen to go in the direction of demolition rather than one of conservation and reusing a building. So this building is going to be somewhat rehabilitated to its 1930s appearance while having to increase spaces near it or around it for current passenger safety and volume. So I was very happy to hear that this building will still be around for the foreseeable future. Okay, and that's it. Thank you.
Thank you, Simon. I really enjoyed hearing your stories of reusing materials and how preservation can be very personal. Our next presenter today is a fellow AmeriCorps Public Ally Taylor from Local First Arizona, telling us about their Green Business Boot Camp.
Awesome. Thank you, Alicia. Let me get my screen pulled up real quick. Oh. All right, guys. So first of all, I just want to say some amazing presenters today with amazing projects that you guys have done, and just very exciting to see a lot of those and to recognize some of them. So just thank you for the work that you guys do. As Alicia said, my name is Taylor Shadron. I'm a public ally placed with Local First Arizona as the Green Team Coordinator. And so I want to give you just a little overview on what Local First's overall mission is. And it's really just to build equitable systems for Arizona's local businesses and communities that create a vibrant, inclusive, and sustainable Arizona economy by strengthening, supporting, and celebrating entrepreneurship, rural and urban community development, racial equity, environmental action, and food access. So we have a variety of teams that take all of those in stride, and we try to work together holistically. And so we really want to just strive to create resilient, future-proofed communities that are able to withstand shocks like the COVID pandemic that happened. And so part of the way that we try to provide resources and to break down those hurdles, especially when it comes to historic preservation, is providing access to capital. And so we do have the Green Business Boot Camp, which is a 6-week program where we talk about water, transportation, energy, waste, and a culture of sustainability. We do that with industry professionals in the room so that we're really connecting resources and building a community for these project plans before we actually get to implementing them. And so through the course of that 6 weeks, organizations get to pick and choose what pieces they want to put into their plan. And then at the end of the program, that plan, along with a water and an energy audit of their existing building, can serve as an application for these loans that we have. And so we do have 2 different loan funds that cover Maricopa, and then one for, Maricopa and Yavapai counties, and then one for Pima County. And so these loans can be up to $10,000 to help with retrofitting costs. The interest rates range between 0 to 5%, depending on what county you're in. And then it's a 3-year payback term. And so some of the other things to be aware of is that it does have to be locally owned business or organization. The owner has to be in Arizona the majority of the year. And then fewer than 25 employees, a brick and mortar physically in the counties that the green funds are available in, and then having been in operation for at least a year. And so by being able to give these character-based loans to businesses and things, it really makes it more accessible, because again, a lot of times the issue is just capital. And so we're just here to try to help even the playing field, and then just make people more aware of the options that you have when it does come to try to preserve these historic buildings. So thank you.
Thank you, Taylor. Now we will be moving into our Q&A session. So if anyone has any questions, please put them in the chat. And I did also want to remind that this webinar will be recorded, or is being recorded, and will be on our YouTube channel soon. I guess I can start with a question. Simon mentioned his favorite project, but Bob, do you have a favorite project that you were a part of?
Oh, there are many, but probably the DeSoto building, because I had the most to do with it, most control over it, I should say. The owner was living out of town, and so I got to have more control. As an architect, you really want to have, we're control freaks. So the more control, the better. But it was great because it's it's close into downtown. It was very visible. I think a lot of people were very interested in the history. It had a lot of artistic aspects to it, as well as it just checked all the boxes. Artistic, it was preservation, and it was sustainable. It's all good.
Thank you. Allow another minute for questions, but I think I'm going to take the lack of questions as the presenters just did such a great job that they explained it so well. Oh, we just got one. Fong asks, can we get some insight into that tension between preservation and sustainability insofar as zoning and municipal subsidies rig how the decisions get made, and how, or do those costs include maintenance like with Adobe?
I'll assume that was directed to me, since that was kind of my point. I'm not sure what kind of extra insight there is. The problem is that until and unless city policies or whatever government entity we're talking about, that's not necessarily the city, but until public policy, let me put it that way, until public policy starts to really recognize beyond just our historic preservation commissions and historic preservation professionals. So the city of Phoenix, as an example, is famously siloed, and it's not unusual among governments. But the people that we work with who really understand these issues and understand the benefits are in one little corner of city government, and other city departments have different agendas and different, well, and legitimately so, right? And whether it's streets or economic development and things like that. So it's a balancing. But I think what I was showing was that balance is perhaps not entirely perceived outside of our narrow preservation world, where we all know each other, and we know. I'm probably not telling most people things that they don't already know in the room here, unless we have new folks in the Zoom call that this is new information for them. But it's always a constant educational battle with our leaders, the rotating cast of characters in city government, council people, but you just have to be vocal and make the good argument. So I don't. The fact is, we're not going to be able to fight back in a huge way against what I see as being the rigging, the so-called rigging of the system. Just be aware that it's there, and that these are arguments that can be used when you're trying to advocate for preservation and against people who are not really looking at those issues.
And I will just underscore the importance of data to really combat those claims that historic buildings are non-sustainable. For instance, as a SHPO, we get a lot of residents who own historic properties in our historic districts that call us to inquire about, hey, I want to change my windows out. I had a sales rep from, I won't name any names, but like X company that told me that I'll be able to save this much money per year if I basically rip all the casements out and replace with this product, this window product. And the price tag that accompanies that quote is quite significant. To replace all the windows on, say, a 1,500 square foot house, you might be looking at upwards of $20,000 to do that replacement. And what we have to do is challenge, okay, $20,000, how much would it actually cost? How much of a energy savings would it actually confer for you to be able to recoup that $20,000 outlay to get those, for the most part, we're looking at petroleum products for these windows to get these sort of non-sustainable engineered windows into your house where you have perfectly good single pane windows that could just be improved with some minor weatherization. So we look at that all the time, and you'll see that is a common, I don't want to say it's not just a marketing tool, but a criticism of historic buildings, that these buildings were not built to really help us understand, desert dwelling, or. But the reality is if you look at a house like, let's say, some of our 20th century Victorian houses, which were the first houses to come in here, and to a certain extent, some of our larger arts and crafts bungalows, they have incredibly high ceilings. Transoms to improve cross ventilation, sleeping porches. There's a whole series of technological choices that were made in construction of these houses, and same thing with our adobe row houses down in the Tucson area. Unfortunately, sometimes we lose that argument, and a classic loss for us, I'll just put it right out there, our State Historic Preservation Office used to be located in the 1893 Evans House, which, for those of you who are familiar with the Capitol Mall area, if you are driving down Washington heading west and you see the Capitol in front of you and you see the Carnegie Library on your left, you see this weird sort of, some folks would call it a spite house, but this weird Victorian that's just surrounded by a contemporary office building. Ashley Harder is given love to the Evans House. We love the Evans House too. In 2020, the State Historic Preservation Office was moved out of the Evans House and consolidated into our Solis office building in back as the Natural Resources Complex. And that was done for a host of budget reasons. But I can tell you one of the main reasons that was lobbed at me was how much the cost of heating and cooling the Evans House was for the state of Arizona, and the need to mothball it now, so that those maintenance costs would not have to be budgeted for. And I can tell you that mothballing a building creates a whole lot of other maintenance problems and maintenance costs. And so this building that we have invested quite a bit of money in, with a new roof and a new mechanical system, new HVAC, is sitting vacant right now. And if we can't get somebody into that building soon, it really is going to be quite a bit of deferred maintenance and cost to get it back up into use. So it's a constant struggle, I think, in relation to that question. I believe it was it Fong that Fong had asked? Not just a municipal issue.
Bottom line
State
budgeting, right? Bean counter budgeting and not looking at the big picture and all these other issues.
And also balancing, I think, Bob, you made a really good point in the beginning of your presentation that, yes, sustainability is a huge factor, and the green aspect of sustainability, the energy conservation aspect, the aspect of not putting materials into our already overburdened landfills, all very important contributions of historic preservation. But then there's this, the more ineffable sort of element of just mixed vintage buildings contributing to our sense of place and our quality of life as Arizonans. I mean, the Capitol Mall, I mean, no offense to lovers of brutalist architecture, we got a lot of that going on there. But there is this sort of grand area of the Capitol Mall, which is marked by having the Carnegie and the Evans House on either side of Washington. And there's a lot of beauty to that symmetry. And, you know, it erodes our sense of place when we lose these buildings, when, especially when they're monumental or the last of their kind. It really behooves us from a sustainability, social sustainability point of view, to really move them forward as we plan for the future of our environments.
And to follow up on your point about the windows, just as an example, this is a place where you're making a point about data and data being important. It is pretty is not difficult these days to do an energy model, an energy study on buildings, and we've had success in showing somebody that wanted to do a wholesale window replacement because they wanted the new Pella window or whatever it is that gives them the super energy performance and the double insulated with low E glass. And we could show that, you know, those, first of all, those windows tend to be very expensive. We're talking, you know, $2,000 to $3,000 an opening sometimes, very easily. And so we can do a calculation and show that the energy savings on a window, which is not the majority of your envelope, the energy savings is going to pay off in maybe 30, 40 years sometimes. So the data does help, and with the technology we have today, it's not as hard to come up with sometimes.
Thank you. And that actually leads into the next question of, regarding the belief that reuse is more sustainable and affordable over time than demolition, what data do you cite to support this concept that they also believe to be true?
Yeah, so that's from Ashley. Hi, Ashley. Speaking for myself, I'm not a terribly academic person, so I don't dig into the data that much. So I'm not sure that I can cite specific data to answer that question. Maybe one of the other reviewers that can.
I can say there are studies. I'm just currently trying to find it. So when I find it, I'll drop it in the chat.
Yeah, I'm afraid I can't add anything to that. I don't have any data to prove the stance on demolition and sustainability. I'm sure that it's a very complex problem, but for example, the airport building I gave an example of in my home place, they were getting ready to spend 40 million pounds on a new airport building, which translates to an awful lot of money in dollars. And that didn't include the cost of demolition or the removal of those materials to somewhere else. So I think the saving, it comes down a lot of times to a certain amount of common sense that is going to be more cost effective to keep a building just from the point of view of demolition and replacement of materials. And as Bob said, there are ways to improve the performance of buildings, and it may not be as obvious as windows. It could be adding insulation in certain places or improving the performance of existing windows and doors that can greatly improve the performance. And it may never be as good as a brand new building made with new modern materials and systems, but then a historic building doesn't look like a modern building. They're going to be different.
Yeah, and I think Donna put it into the chat as well. Donovan Ripkema's group, Place Economics, has done quite a bit of, I wouldn't say original work in data collection, but compiling data from communities that have done such studies. So I would refer you to his work, and he's published, oh my gosh, if you go to his website, he's got studies for municipalities as well as state governments. He just recently did one for the city of Phoenix. I do not believe it involved looking at actual numbers for volume of demolition added to landfills, but he certainly does bring up that research in the Phoenix study. I will say that the trend right now is to talk about a practice called deconstruction, so that when you are demolishing a historic building, you are minimally recognizing that there are character-defining elements of the building that could be recycled and placed into current buildings that require some element of restoration or rehabilitation, or could possibly be carried forward into new construction. I personally, I have a hard relationship with deconstruction. I'm not there yet. I mean, from a pragmatic point of view, you know, for those of us who live in Arizona, we are a state where our history is a history of development and redevelopment. That's what we do. I mean, Phoenix is from the ashes. We redeveloped the canal system of the Hugum, and we're going to continue to redevelop this city. But at the same point, the work that I do as a preservationist, I feel like my time is better invested in trying to find those solutions before we get to a demolition place. But I don't want to shortchange the fact that reconstruction and the salvaging of even things that like timbers, rafters, healthy wood is part of the sustainable solution to managing destruction.
Yeah, I was going to recommend checking out Stardust Deconstruction out of Phoenix, as well as if you would like more information. We did do a webinar on deconstruction about a year ago, and that recording is on our YouTube, which I put the link in the chat. And I guess that goes into the last question that we had, which was, can you say approximately what percentage of historic buildings or their materials are able to be recycled or salvaged on average?
I might leave that one for the architectural professionals, because I mean, I think it would really depend on you know, the vintage of the building and the materials of a building. I would imagine with an adobe building, there is not a high degree of salvage ability. I imagine with a poured concrete or a cast concrete building, there wouldn't be. I mean, I don't know. I'll leave it to you guys.
Yeah, it depends on how much trouble you're willing to go to do it, because most of a building is possible to either be salvaged and reused or somehow otherwise diverted. So even concrete, you can have it, you know, ground up and use it as aggregate. Wood, if it's splintered and broken, you're probably not going to use it for anything. But there are plenty of businesses right now that are salvaging vintage wood and using them for interesting finishes, if not actually structurally. You know, the bulk of a building's mass usually is in that walls and roof structures. The rest of it, you know, bricks. We have old brick buildings deconstructed and palletized all the time. In fact, we're always looking for brick to use in restoration work. So we're fortunate that we have a few places around town that deal in those.
Actually, now that I think about it, Bob, and this goes back to what Simon was talking about, I never think about when we deconstruct and palletize a building for preservation's sake. I get sad and I just think, well, there goes that. You know, maybe we'll get the building back, maybe we won't. But a great case of where we got the building back and then some is the Esmond School in Vail, where the Vail Preservation Society deconstructed a turn of the century, and when I say century, I mean 20th century, so 1901 or 1902. I think it's called a section foreman's house. So this was the dude who worked for the railroad and it was essentially responsible for that section of the railroad coming through Vail. This was a territorial style building, wood frame construction that existed on a parcel which had to be moved and then had to be moved again. And the Vale Preservation Society worked to deconstruct that building meticulously, like numbered the pieces of wood, numbered each window element, and then used the services of the vocational education department of the nearby high school and taught students how to essentially build a 1902 house out of those deconstructed parts. And that house now lives its new life in the courtyard of the Esmond School, where it is used by the grade schoolers to interpret local history. They have a museums club and they do rotating museums displays in this house. And parents can come and see what the students have done and learn about Vale's history. And it really is, you know, sort of the best case I've seen out of taking I mean, arguably you could say the value and impact of that building is so much more magnified in terms of training children to become tradespeople for preservation, and then training this whole next generation of really young people to have an interest in historic preservation. I mean, the value of that house is, I would say, almost increased by its demolition, the impact. So that's very rare, though, very rare.
Simon, do you have anything to add to that?
Yeah, the school did arrive in a number of pieces, but it was moved by road. The essential square or rectangular building was jacked up and moved by truck at night. But the roof had to be rebuilt, and many portions of the house had to be reconstructed, including the windows, of course. But wood frame buildings, any building that is dismantled, is a very labor intensive and careful process. So that's going to add to the cost of the building, whether it's moved or whether it's taken apart piece by piece. And somebody has to do the right kind of documentation so that the pieces can be reused again, either in part or in whole, when the time is right.
Thank you. I did kind of want to add to Bob's claim of, like, sometimes you have those unusable and like splintery pieces of wood. I know my previous high school's construction class was able to take those to be able to learn how to use the different tools on them, be able to reuse them that way. But I do see the time, and I do want to let you, I don't want to take advantage of your time. So thank you all for coming today, and this will be on our
So
YouTube
yeah,
soon.
thank you all as well. And I want to put one final plug in. So for those of you who have enjoyed this programming and want more, we have a in-person annual historic preservation conference that we produce, that is APF and the State Historic Preservation Office. We call it Preserve AZ. Now you are on our email list and you should be getting information about that. But if you want to mark your calendars for October 25th to 27th, we will be in the Old Pueblo at the Tucson Convention Center. Our theme is very similar to what we were talking about today, history in the balance. So come join us. And again, thank you, Alicia, for moderating. Thank you, Simon and Bob, for just presenting just such great projects. And thank you very much, Taylor, for helping bring it all together for us.
Thank you. Have a great day.
Thank you.